Imagine a complex dance performed by a robotic arm, moving with precision and grace. But what happens when that dancer suddenly gets stuck, unable to move in a desired direction, even though it appears physically possible? This intriguing limitation is often due to something called a kinematic singularity, specifically wrist and elbow singularities, which are critical concepts in understanding robot movement. Wrist and elbow singularities in robotic manipulators occur when certain joints align in such a way that the robot loses one or more degrees of freedom. This means it cannot move its end effector in particular directions, even if it has enough motors and joints to do so normally. This alignment can lead to infinite joint velocities, making precise control impossible and potentially damaging the robot. The root cause of these singularities is found in the robot's kinematics, the mathematical description of its motion without considering forces or torques. When the robot's joint axes become collinear or aligned, the transformation matrix, known as the Jacobian matrix, loses rank. A loss of rank means its determinant becomes zero, indicating that the inverse Jacobian, which maps end effector velocities to joint velocities, becomes undefined. This mathematical breakdown physically translates to a loss of the robot's ability to move freely in certain directions, effectively creating a locked position. For an elbow singularity, the robot's shoulder and elbow joints align, causing the arm to become fully extended or fully folded back on itself. In this configuration, moving the wrist left or right becomes ambiguous or even impossible, as two joint axes effectively merge. Wrist singularities occur when the axes of the wrist pitch and yaw joints become collinear, typically when the wrist is straightened out. This leads to an inability to change the orientation of the end effector about the axis of alignment, and also an infinite number of solutions for a desired movement, which is problematic for control. To address these issues, engineers and programmers often employ several strategies. One common approach is careful path planning, where robot trajectories are designed to avoid critical singular configurations. Another technique involves using redundancy, adding extra joints to the robot to provide more pathways around singular points. Software-based solutions can also detect an approaching singularity and adjust joint velocities to prevent the robot from entering the problematic region, or use damped least squares methods to approximate solutions even at singular points. Understanding these singularities is not just theoretical. It is crucial for designing robust and reliable robotic systems. For instance, 6-axis industrial manipulators with a spherical wrist are highly susceptible to wrist singularities, while human-like robot arms with more degrees of freedom might encounter elbow singularities more frequently. Being aware of these configurations allows for more intelligent robot programming, ensuring smooth operation and preventing unexpected halts or dangerous accelerations. By appreciating the mathematical and kinematic origins of wrist and elbow singularities, you gain a deeper insight into the complexities of robot motion. This knowledge empowers you to anticipate potential problems in robot design and task planning, ultimately leading to more efficient and safer robotic applications. It transforms a seemingly abstract concept into a practical tool for effective robotics engineering.
If you love robotics, like, subscribe, and keep building with us.